Good morning to all. I am Vinodini, working as an assistant professor in the Department of Pharmaceutical Technology. It is my pleasure to present the session on heat and mass transfer operation. It is a core subject that deals with the fundamental principles and governing the transfer of heat, mass, and momentum in pharmaceutical processes. In this presentation, I am going to explain the basic concept of heat transfer, including conduction, convection, and radiation, along with an introduction to mass and momentum transfer and their relevance in pharmaceutical technology. I hope this session will help you to understand the practical significance of these principles in pharmaceutical manufacturing and process design. And the subject code was PY3601 and it's belonged to OR 2021 regulations. Next, we move on to the course objective of the course. Okay, here the main objective of this course is to recognize the principles and applications of heat transfer and to understand the fundamentals of mass transfer operation, and these principles are applied in manufacturing, pharmaceutical manufacturing, to control temperature, moisture content, separation process, and reaction condition. And the next slide explains the course outcome. So these are all some points of the course outcome. Uh, by the end of this course, students will be able to explain conduction, convection, and radiation modes of heat transfer and solve numerical problems related to them. Student will also understand the working principles of heat exchangers and various mass transfer operations used in the pharmaceutical technology. In the next slide, these are all the course content belongs to the unit 1. So unit 1 is that fundamental concept and conductive heat transfer. Okay, so in this unit we are going to see about introduction to heat transfer operations, heat transfer processes, heat, mass, momentum, and heat transfer processes, conductors and insulators, and Fourier equations, thermal conductivity and resistance, linear heat flow through homogeneous wall, and heat flow through cylinder, sphere, and extended surfaces, that is fins, and problems related to this conduction heat transfer. These are all the topics we are going to see in the unit 1. And next unit 2 is that heat transfer through by conduction. Okay, so in this unit we are going to see about Newton's Richmond's law, Plum coefficient of heat transfer, convection, free and forced convection, dimensional analysis and its application, factors affecting the heat transfer coefficient in free and forced convection heat transfer, and overall heat transfer coefficient, and some problems related to convection. So these are all the topics we are going to cover in the unit 2. And in the unit 3 is that heat transfer by radiation. Okay, so in this unit we are going to discuss about radiation heat transfer, concept of black and gray body, monochromatic total emissive power, and Kirchhoff law, Planck's law, Stephen Boltzmann law, and then heat exchange through non-absorbing media, and then problems related to heat transfer by radiation. So these are all the topics we are going to cover in the unit 3. And then in the unit 4 is that mass transfer diffusion, that is extraction absorption. Okay, so in this unit we are going to see about introduction to mass transfer, law of molecular diffusion in gases, liquids, and solids, and introduction to absorption, equilibrium in gas liquid system, minimum liquid rate, height equivalent to theoretical plate, liquid extraction, and solvent characteristics. These are all the topics we are going to cover in the unit 4. And then module, that is unit 5, is that distillation and adsorption. Okay, so in this unit we are going to see about concept of distillation and vapor liquid equilibria, Henry's law, volatility, relative volatility, and method of distillation, simple or differential distillation, Rayleigh's equation, steam distillation, adsorptions, type of adsorptions, nature of adsorbents, equilibria, absorption isotherms. These are all the topics we are going to cover in the unit 5. And the next slide it move on to the subjects. And in that, the first topic is that introduction to transfer process. So in the transfer means here heat transfer only. So here we can start heat and mass transfer studies how thermal energy, that is heat and matter, moves between system. So driven by the temperature difference for heat, that one is conduction, convection and radiation, and concentration differences for mass, that is diffusion and convection. And then heat transfer involves energy moving from hot to cold. Okay, so via vibration, uh, fluid movement or electromagnetic waves. Okay, and mass transfer involves movement of chemical species, that is like water, vapor or gas, from high to low temperature, crucial for process like drying or evaporations. Okay, and next one is that heat transfer. Heat transfer is nothing but energy flows from hot to cold due to temperature gradient. Okay, so temperature is moving from one temperature to another temperature. So changing a temperature is called a temperature gradient. Okay, so conduction, here the three type of transfer processes there. One is conduction. So that one is heat through direct molecular vibration. That is like a hot pan handle. And then convection, heat transfer via fluid motion, warmer air rising, that one is an example. And radiation, heat transfer via electromagnetic waves, that's example is that sun's warmth. Okay, and then mass transfer is that movement of chemical species from high to low concentration. Okay, so here diffusion means spontaneous mixing, and convection, mass carried by fluid flow. And then in the driving force, a gradient is a force causing the flux. So heat means temperature gradient. Due to temperature gradient, it moves hot to cold temperature. Mass means due to concentration gradient, it moves to high to low. Okay, so these are all the two concept in the heat and mass transfer, and two difference between the heat transfer and mass transfer. And then what is heat first of all? So heat is transferred in three main ways. One is conduction, that is direct contact, and then another one is convection through fluid movement, and last one is that radiation by electromagnetic waves. Okay, so always moving from hotter to cooler areas to reach equilibrium. Okay, so involving solids, liquids, and gases through molecular vibration or fluid currents. And then the next slide about a mass. So mass transfer is a movement of mass from a higher concentration to a lower concentration. Okay, so driven by the concentration gradient and occurring through mechanism like diffusion or convection, essential in processes from drying and distillation to biological functions like kidney filtration, like that. Okay, so it moves substances within the same place or between different phases. Okay, gas to liquid, liquid to gas, until equilibrium is reached. It can changing the phases. Okay, next one is that momentum. So momentum transfer is the exchange or movement of momentum between object or parts of a system. So happening through direct collision like billiard balls hitting, or interactions like fluid layers rubbing are called viscous drag. So it follows Newton's third law. That is Newton's third law is that for every action there is an equal and opposite reaction. Okay, so and conservation of momentum, meaning momentum is not lost, just redistributing after from faster to slower part or objects. This process explains rocket propulsion, fluid flow, and how forces act on that. Okay, these are all the about the momentum. And then next slide is that three types of heat transfer mechanisms. First one is that conduction. Okay, so the fundamental process where thermal energy is transferred from a warmer area to a cooler one, within a material is transferred to as heat conduction. Okay. So heat conduction is driven by the temperature gradient between the areas. This transfer occurs as a kinetic energy of vibrating particles is passed from one to another, moving the heat through the substance until a uniform temperature is achieved. So best example is that, see, a common example of conduction is heating a pan on a stove. The heat from a burner transferred directly to a pan surface. So temperature measures the amount of kinetic energy processed by a particle in a sample or matter. The more kinetic energy of material has its internal temperature will be the higher. Okay. So next one is that convection. Convection is a transfer of heat through the movement of fluids, where fluids means liquids or gases, where warmer, less dense parts rise and cooler, denser parts sink, creating circulating currents and distribute the heat. So best example is that boiling water in a pot, rising steam from a hot drink. So this one is the best example of the convection. And next one is that radiation. So radiation is one of the three ways heat transfers. The other two being a conduction and convection. In contrast with the convection and conductions, radiation does not require a medium to travel through. So radiation is a transfer of thermal energy from a hot surface to a cold surface by electromagnetic waves. So mostly through infrared radiation. In contrast to conduction and convection, radiation can transfer energy through an empty space. In simpler terms, radiation can happens in a vacuum or through matter. So example is that sunlight warming the earth. See this picture. This is the best example for the radiation. And another one is that conductors. So conductors is nothing but it carrying the electricity. That one is the electrons. Okay. So conductors, materials that allow electricity to pass through them are called conductors. Okay. So conductors are free moving electric charges. That one is an electrons. So example of conductors include metals, humans and animal bodies and the earth. And see the next point. A metal plate is buried deep in the ground and connected to building using a thick wires. So household wiring has three wires, live, neutral and earth. So live and neutral carry current. The earth wire is connected to the buried metal plate. So this one is a method for the earthing system in the house. So earthing prevents electric shock and protect the appliances during faults. Next one, application of the conductors. So what are the applications, real time applications are that we can see now. So conductors are quite handy in the variety of situations. Okay, so these are useful in the variety of situation. As an example, mercury is a frequent component of thermometers used to measure body temperature. That one. And next, aluminium is used in the manufacturing of food storage foils. It also used to make fry pans that can hold the heat for a time. Okay. And the next one, iron. Iron is a typical heat conducting material used in a car engine protection. And then one iron plate is made of steel to quickly absorb. And final one is that conductors are used in automobile radiators to transfer heat away from the engine. So these are all the applications involved in the conductors. And next one is that examples. What are the examples? Silver is the most effective conductors of electricity. However, because silver is expensive, it is not used in industry or for energy transmission. And next one, copper, brass, steel, gold and aluminium are excellent electrical conductors. In the shape of wires, we use them in electric circuits and systems. And then mercury is a great conductor of liquid. As a result, this material is used in the variety of instruments because the atoms are so far apart. Gases are poor conductors of electricity. As a result, they can't conduct electrons. Okay, and then insulators. So conductors conduct the electricity, insulators not conducting the electricity. Okay, this is a main difference between the conductors and insulators. See this point, most non-metals such as glass, porcelain, plastic, nylon and wood having high resistance to electricity. Okay, so these materials are called insulators. So insulators do not allow electrons to move freely through them. When a charge is given to an insulator, it remains at a same place and do not spread over the surface. So insulators can be charged by rubbing or by induction. So this is why nylon or plastic combs are preferred for combing dry hairs. Okay, so charging on metal flow through a human body to a ground. Both human body and the earth are good electrical conductors. And then applications. So insulators are widely used because they prevent the flow of electrons. Thermal insulators reduce heat transfer and are used in the thermoplastic bottles. And then thermal insulators are also used for fireproofing walls and ceilings. And then sound insulators absorb sound and heat and help control noise levels. They are used in buildings and conference halls to reduce the noise. And electrical insulators prevent the flow of electric current. So they are used in circuit boards and high voltage systems. Electric wires and cables are coated with electrical insulators for safety. And some examples of the insulators are, because of its high resistivity, glass is the best insulator. And then plastic is a good insulator and is used to make a variety of items. And rubber is a commonly utilized in the manufacturing of tires, fire resistant clothing and shoes. This is due to the fact that it is an excellent insulator. And then next one is that Fourier's law. So it is that the physical law governing the transfer of heat through a uniform material whenever a temperature difference exists. Okay, so by a conduction mode was given by the French scientist, that one is a Joseph Fourier. Okay, so Fourier states that the rate of heat flow by conduction through a uniform material is directly proportional to the area normal to the direction of the heat flow and the temperature gradient in the direction of the heat flow. Okay. Mathematically, the Fourier's law of heat conduction for steady state heat flow is given by Q is directly proportional to A minus dt by dN. Okay. So now this equation changes to Q is equal to. So to remove that proportionality constant, we are giving a constant here. So Q is equal to minus Ka dt by dn. Okay. So to remove this proportionality constant, we are adding a constant K here. So Q is nothing but rate of heat flow or transfer, and A area normal to the directions to the heat flow, and T means temperature, N means distance measured normal to the surface, that is the length of the conduction path along the heat flow. And then dt by dn is nothing but rate of change of temperature with the distance measured in the direction of heat flow. And k is a constant of proportionality. It is a thermal conductivity. Here one negative sign is there. Now what is the meaning of the negative sign? Is incorporated in equation because of the temperature gradient is negative. So temperature is changing, right? So that minus will become there. And then Fourier's law for a steady state unidirectional, that is a x direction heat conduction, then becomes Q is equal to minus Ka dt by dx. It becomes small q is equal to capital Q by A is equal to minus K dt by dx. So capital Q is nothing but rate of heat flow. Okay, and small q is a heat flux, and the heat flux is defined as the amount of heat transfer per unit area per unit time, or rate of heat transfer per unit area. That one is a q by a. Okay, so this is about the Fourier's law, unidirectional, and about this Fourier's law is nothing but it is a mathematical representation of a heat transfer by the conduction process. Okay, I hope you all understand the sessions. Thank you.